Every segmental bridge is a major feat of engineering and construction. But the Ontario Ministry of Transportation and Communications, MTC, is particularly proud of its success twinning the old Burlington Bay Skyway. This was the first large-scale application of cast-in-place, pre-stressed concrete segmental construction in Ontario. The bridge connecting the Niagara Peninsula and Upper New York State with the major urban areas around Toronto is a vital link in the transportation system of Southern Ontario. The original bridge is a 4-lane, high-level crossing for the Queen Elizabeth Way over the entrance to the harbor at Hamilton, Ontario. The old Burlington Bay Skyway was constructed in 1958. A truss-type bridge, it was considered a major construction triumph at the time. But with ministry projections indicating continued traffic growth and increased congestion on the old Skyway, it was decided that a second bridge was needed. A new 5-lane structure to handle southbound traffic, while the older bridge would handle northbound traffic. This would effectively double capacity to meet traffic demands into the foreseeable future. The new 2.2-kilometer long structure was designed in-house by the MTC Structural Office. All design work was carried out according to the provisions of the Ontario Highway Bridge Design Code. Substructure construction began in July 1983. Due to poor soil conditions at the site, large piled footings were needed. Precautions were taken to keep noise levels caused by pile driving at a minimum. Due to the high local water table, continuous dewatering was required. In order to minimize foundation settlement of the existing Skyway, this dewatering proceeded at a controlled rate. Pile layout and footing sizes were standardized for maximum economy of construction. Work progressed through the winter. Pier dimensions were also standardized. Reusable, prefabricated timber and steel formwork was used for all the piers. Easy to remove, reassemble on the ground, and use again. Similarly, each pier capping beam was the same shape, making it possible for the contractor to use standard prefabricated steel forms. The reinforcing steel cages were assembled on-site on a custom-built jig. Once fabricated, the cage was lifted into place in the assembled formwork. Concrete was placed. Work progressed on all piers simultaneously in a carefully coordinated manner to maximize efficiency and economy. The reinforced concrete deck was detailed according to the latest ministry procedures for ensuring deck durability. Concrete was delivered to the deck and placed in sections in leapfrog fashion. Segment construction began with the placement of the bottom slab and web reinforcing steel. Formwork for the inside top slab and inside webs was then moved into casting position. Reinforcing steel and post-tensioning ducts and bars were installed. During each construction cycle, immediately prior to the concreting of the segments, a construction control survey was carried out. This survey enabled the correct positioning of each new segment, added onto the cantilevers, thus ensuring accurate matching at closure. Typically, concrete placement began with the bottom slab. The concrete was delivered through the webs and through openings in the top slab forms using elephant trunks. To ensure that the concrete remained workable long enough, super plasticizer was added to the ready mix on site, effectively increasing the concrete slump to about 150 millimeters. Finally, the top slab concrete was placed. Troweling and screeding was done by hand. With the completion of the stressing, marking the end of a construction cycle, the formwork was released. The form traveler could now be moved ahead, and a new cycle begun. Finally, it was time to build the closure segments. The 3 closure segments along the bridge were the final step in the construction of the main spans. The end span closure segments were built first. Concreting began in the afternoon and carried on into the evening to minimize the chance of thermal-induced movements occurring in the spans. Each unit was supported from large steel beams clamped across the closure gap. The mid-span closure segment was placed last on the 30th of November, 1984, a step ahead of winter weather that would have delayed completion of the main spans until the following spring. The ministry was very pleased with its experience twinning the Burlington Skyway. The success of the project proved that the alternative bidding procedure, with multiple design options, can result in considerable financial savings. The $38.8 million cost of the project was less than the ministry's own estimates, and only 2.1 times the cost of the original bridge built a quarter of a century earlier. The old Skyway will be completely rehabilitated, allowing it to carry northbound traffic exclusively. Emphasis was placed on constructability at the design phase, with special emphasis on standardization and repetition. Improved design codes and the use of higher strength materials also resulted in efficiency and savings. The use of epoxy-coated reinforcing steel, box girders fabricated from atmospheric corrosion-resistant steel, minimizing the number of deck expansion joints. These features and more to ensure a durable structure and good long-term value for the dollar. Just some of the reasons allowing Ontario to keep pace with the latest in bridge building technology. The new James N. Allen Burlington Bay Skyway, meeting the ongoing challenge of keeping Ontario on the move.